The field of biomechanics is a complex one, covering a wide array of topics, and including a variety of subdisciplines. Among these are kinematics and kinetics. They represent fundamental branches of the biomechanics tree, and are key aspects of the field. Kinetics examines the forces that cause motion, while kinematics examines the motion of objects without examining the forces involved. Both can be further divided into either angular or linear aspects. Linear kinetics is the branch of kinetics that deals with the cause of linear motion specifically. Within linear kinetics, you will find Newton's three laws of motion, as they're the key concepts examined in this branch. Newton's three laws are comprised of 1. The law of inertia, 2. The law of acceleration, and 3. The law of action and reaction, and they provide the basis for our understanding of the cause of movement as related to biomechanics. For this presentation, I will be focusing on Newton's second law, the law of acceleration. It is defined as the change of motion being proportional to the force impressed and being made in the direction of the straight line in which that force is impressed. I understand Newton's second law, the law of acceleration, to represent the relationship between net force, mass, and acceleration, with the relationship being proportional, which is shown in its corresponding equation, force equals mass times acceleration, by the fact that mass and acceleration are simply multiplied together. I use my understanding of the formula for the law to remember and interpret the meaning of the definition. An example of Newton's second law applied to sport can be found in the sport of rugby. Many parts of the sport involve the law of acceleration to a great extent, including in the scrum and mauls, but it is more simple in a head-on tackle or a ruck. A ruck is formed when at least one player from each team contests possession of the ball by entering into contact with one another over the ball. Rucks typically begin immediately following a tackle, while the players involved in the tackle as well as the ball are still on the ground. The ruck is an opportunity for possession to change team, depending on which team wins the ruck. Players engage in head-on contact, with the goal being to move the opponent backwards. Players cannot enter a ruck from the side. The player with the greater mass will have the advantage, largely because they require greater force to move than the player with less mass, due to Newton's second law. The same concept can be applied to many different aspects of rugby, including mauls, scrums, and tackles. Now I will illustrate some examples of where we can see the law of acceleration in the sport of rugby by examining rucks, tackles, and scrums. So right here is a good example of a ruck. You can see the player in white and the player in yellow making head-on contact right there, and you can see how they are applying force directly into each other. You can also notice how secondary players will join on, him, and they will add additional force. Here's another one-on-one ruck where the yellow player and the white player are entering contact. The white player is entering very rapidly while the yellow player is relatively stationary. So the white player is creating a great amount of force and applying it directly into the yellow player. In this clip, you can see the red player clearly has greater mass than the blue player and is applying greater force, which results in a failed tackle on the part of the blue player as he flies off in this direction. A scrum is another great example of Newton's second law. It's similar to a ruck in this context, as players from both teams are trying to push their opponents in the opposite direction over the ball beneath them. There's invariably one side that has a greater total mass, which gives them the advantage in that regard, because they require more force to be moved. Newton's second law, the law of acceleration, is clearly illustrated by any contact sport. Rugby provides many great examples of this law in action, as well as many, if not all, of the biomechanics concepts we have discussed this year in class. I hope you enjoyed my presentation. Thank you.